Hello and welcome. In this video, we're going to be going through pure one integration. This is going to be a one-stop video. That's all you need to solve the integration questions on pure one. This is the no-nonsense guide to solving. So let's get into this straight away. So first of all, integration is basically denoted by this sign over here. Let's say if I want to integrate an expression that looks like this, x squared dx. Always in integration, I have to have the integration sign, which is similar to sum. It's basically, it looks like an S because it denotes a sum. Okay, and dx as well, I need it to be there. These two, when they're there, I can complete the integration. So this is going to be, it's very easy. The power rule for integration is add 1 to the power, so x squared. Adding 1 to 2 becomes 3, so this becomes x to the power of 3. That's adding 1 to the power. And divide by the new power, so x cubed over 3. Since this is an indefinite integral means we don't have bounds. We need to have something that's called constant of integration. On the other hand, if we have the same thing, but we have bounds, these are called, this is the lower bound, this is the upper bound. X squared dx, okay, I will integrate it again, add 1 to the power over the new power, but then I have to evaluate using my lower bounds. How do I do that? I substitute the upper bound first, so it becomes 2 power 3 over 3, and then subtract when I substitute the lower bound, so minus, and then substituting the lower bound, so this becomes 2 cubed is 8 over 3 minus 1 cubed is 1 over 3, so this is 7 over 3. And in indefinite integral, I do not need the constant of integration. Another thing, we can use the definite integral, the one with the upper and lower bounds. This helps me to find the area under the curve. So let's straight get into solving. This is just a quick refresher. We're going to solve lots and lots of questions for pure one for both Edexcel and Cambridge. It's very, very useful video, so stay tuned. And I'm going to be doing this series for all the pure topics, so comment down below which topics you would want. And very, very quickly, I have the same series for mechanics. Go check it out. I'm going to leave a link to it on the top right hand corner, as well as I'm going to leave a link to the Udemy course. It's a very, very, very good intensive course for mechanics students at Edexcel and Cambridge. It's literally all you need with lots of solved past papers. It's me solving and explaining every single topic thoroughly. It's on Udemy. If you email me on abdurrahman.elminiawi@outlook.com, it's the email in the description. I'm going to send you a discount code for the course. Enjoy. I'll leave a link to them on the top right hand corner. So let's start the first question by reading. So this first question tells me that given that x minus 5 times 2x plus 1 times x plus 3 equals this, where I have to find a and b. Basically, a and b are constants. Let's try to find them. This is super easy, so I'll just expand. So I'll start straight away. So x times 2x is going to be 2x squared. X times 1 is going to be x, so plus x. And then minus 5 times minus 2x is minus 10x. Minus 5 times 1 is minus 5. This is basically these two brackets expanded. I still have this one, so I'll add it over here, x plus 3. Now, let me simplify this bracket. Let's see if I have any like terms. X minus 10x, that's going to be minus 9x. So let me write 2x squared. This is going to be minus 9x minus 5. And then all multiplying to x plus 3. So let's multiply again. 2x times x, 2x squared times x is 2x cubed. 2x squared times 3 is basically plus 6x squared. Minus 9x times x is minus 9x squared. Minus 9x times 3 is minus 27x. Minus 5 times x is minus 5x. And finally, minus 5 times 3 is minus 15. So now let's simplify. I have x squared minus 9x squared is minus 3. So 6x squared minus 9x squared is minus 3x squared. Minus 27 minus 5 is basically minus 32x, and then minus 15. So over here, I can compare the coefficient. So a is going to be basically what's multiplying x cubed. So that is 2 over here, so a equals 2. B is what's multiplying x squared, so b equals minus 3. And that is going to be my answer over here. And this is minus 32, then minus 15, which is correct. Now, let's use that. It says, hence, use that information, okay, to find the integration of this expression over here. So I know that this is basically my first expression, so I can rewrite it in this form, knowing that a is going to be, so this is going to be integration of this numerator is basically this, so I can rewrite it here, knowing a and b, so it's going to be 2x cubed. I just found that, minus 3x squared minus 32x minus 15 all over 5 root x. Okay, in integration, what I like to do is always write, remove the roots and change it to, let's say, for example, power 1 over 2, because I know root x is power 1 over 2. And I cannot forget the dx. So how to do that? We need to first simplify it and write it in an integratable way. So this basically is every term divide 5x power half. So this is going to be integration of big bracket 2x cubed over 5x power half minus 3x squared over 5x power half minus 32x over 5x power half minus 15 over 5x power half. And then I can use the power rule for each term. But first, let me simplify a little bit. This term is going to be, so 2 over 5 x cubed divide x over x power 1 over 2 is basically whenever you have, let's say, x squared, x cubed times x squared, you know the answer is going to be x and we add the powers. So x power 5, 3 plus 2 is 5. When we have an x cubed over x squared, the answer is going to be x, but we subtract the powers, so it becomes x power 1. So over here, we're going to do the same. We're going to subtract the powers. So this x cubed over x power half is basically x power 3 over x power 1 over 2 is going to equal x power 3 minus 1 over 2. So 3 minus 1 over 2 is 2.5, or basically 5 over 2. Right? So 3 minus 0.5 is 5 over 2. So this is going to be x power 5 over 2 minus 3 over 5 x squared. So 2 minus half is going to be 1.5, or 3 over 2 minus 32 over 5. 1 minus half is going to basically be half, and then minus 15 over 5 is basically 3. And this, I don't have anything here, so I will not subtract. However, I would like to get this x on top. So to do that, I will need to write it as x power negative 1 over 2 instead of 1 over 2 dx. Now I didn't even start integrating. I just wrote it in a way that's integratable. So let's do the integration right now. So this is going to be same rule, add 1 to the power, divide by the new power. So 2 over 5x, we add 1 to the power, 5 over 2 plus 1 is basically 7 over 2, and divide by the new power. Dividing by 7 over 2 is the same as multiplying by 2 over 7. That's the same thing. Minus 3 over 5 x, 3 over 2 plus 1 is 5 over 2, and then divide the new power. So dividing 5 over 2 is the same as multiplying 2 over 5. Minus 32 over 5 x, 1 to half, add 1 to half is going to be basically 3 over 2. Divide by 3 over 2 is the same as multiplying 2 over 3. And then minus 3x, adding 1 to negative half basically makes it 1 over 2. And then dividing by 1 over 2 is the same as multiplying 2 over 1 or multiplying 2. And then I need to add the constant of integration because this is a non-definite or an indefinite integral. So all I have to do here is just simplify. So I'm going to do it here on top. So to simplify this, this is going to be 2 over 5. So 2 times 2 is 4. So this is going to be 4 over 5 times 7 is 35. X power 7 over 2. Minus 3 times 2 is 6. 6 over 5 times 5 is 25. X power 5 over 2. Minus 32 times 2 is basically 64 over 5 times 3 is 15, x power 3 over 2, minus 3 times 2 is 6, so minus 6, x power 1 over 2 plus c, and that is going to be my final answer. Okay? I hope it's clear. Let's erase a little bit and go straight away for the next question. So over here, this question tells me, given that a curve has the equation y equals f of x, given that f dash of x is this, ax minus 12x power 1 over 3, where a is a constant, f double dash of x is 0 when x is 27, the curve passes through the point this, find the value of a. Okay, here it's not only integration we're gonna look at, also differentiation, because they go hand in hand. So what does the question want? It wants us to find this. So first of all, I know that if I differentiate f of x, I will get f double dash of x. So let's differentiate. So d f dash of x by dy, or like differentiate f of x. So f double dash of x is going to be the differentiation of this. So what is the differentiation of a to a multiply x? That's going to basically be a minus differentiation is basically the power times the coefficient and subtract the power by 1. So 1 over 3 times 12 is going to be 1 over 4. X power 1 over 3 minus 1 is going to be minus 2 over 3. This is the differentiation over here. So it tells me that f dash of x equals 0 when x is 27. So this is going to be 0 when x is 27. So instead of x, I'm going to put in 27 power negative 2 over 3. So a is basically going to equal, I'm going to move this to the other side, becomes plus. So a is going to equal 1 over 4 times 27 power negative 2 over 3. So that's going to give me an a value of oh, here, 1 over 3 multiply 12 is not 1 over 4, it's basically 4, because this is 4, this is the mistake. So let's erase it real quick. So this is 4, 4, and 4. So now the answer over here is going to be 4 over 9, and that is going to be the answer for A. So A is equal to 4 over 9. Now, the question tells me that I need f of x, okay? So I start like this. I start from f of x. If I want to go to f dash of x, I differentiate, so dy by dx, differentiate. If I want to go back, I integrate. So I have f dash of x, now I know what is a. In order to get f of x, I need to integrate. So let's do that real quick. Over here, what we will do is that we will rewrite f dash of x as, now we know what is a is 4 over 9 x minus 12x power 1 over 3. So to get f of x is going to be basically integration of 4 over 9x minus 12x power 1 over 3 all multiply dx. I cannot forget to multiply by dx at the end. So now what we will do is we will complete the integration. This is going to equal 4 over 9 x squared times 1 over 2, because add 1 to the power, divide by the new power. So I added 1, it became 2, and then divide by 2, which is the same as multiply by half, minus 12x. 1 over 3 plus 1 is basically 4 over 3. And then I need to divide by 4 over 3, which is the same as multiplying 3 over 4. And then I'm not done. This is an indefinite integral, so I have to add c over here. So let's simplify real quick. 4 and 2 will cancel. This becomes 2. So this is 2 over 9 x squared minus 12 and 4 will cancel. It becomes 3. 3 times 3 is 9. So it's going to be minus 9 x power 4 over 3 plus c. So now this is f of x. Am I done? No, I still don't know what is c. Okay, so how do I do that? It's from this third information piece over here. It tells me that the curve passes through the point 1 and minus 8 so the curve, it's talking about f of x, okay? The curve, which is this curve, okay? Y equals f of x. So f of x passes through this point. That means that when x is 1, y is minus 8. So over here, I know that this is f of x equal, and this is equal to y as well. So when x is 1, y is 8, so 2 over 9. When x is 1, minus 9 times 1, or 4 over 3 plus c, y is equal to minus 8. Now I can solve to get my c value. So this is going to be 2 over 9 minus 9, which is plus c equals minus 8. So 2 over 9 minus 9 is basically the same as 2 over 9 minus 9. That's going to give me negative 79 over 9 plus c equals minus 8. So adding 79 over 9 to both sides will give me the value of c. So c equals negative 8 plus 79 over 9, which is going to equal 7 over 9. So you have to rewrite everything. Now we know that c is this. Okay, so we'll just leave it. So we have to rewrite, saying that f of x is going to equal 2 over 9x squared minus 9x power 4 over 3 plus 7 over 9. And this is going to be your final answer. Okay, let's move on to the next question. We can delete those. We don't need it anymore. Let's erase all of this. Okay, now let's try and do this question. This question says that there is a curve C and it has an equation y equals f of x where x is greater than 0. F dash of x is this. The point P 4 minus 1 lies on C. Find the value of the gradient of C at P. Okay, so when we talk about finding the gradient, we talk about differentiation. I'm going to do a full differentiation pure, also all one-stop video very soon. So stay subscribed so you don't miss it. So part AI tells me find the value of the gradient of C at P. So to find the value of a gradient for a curve at a point, you substitute the x of that point. You substitute the x of that point in the first derivative. Okay, and I'm gonna go through that thoroughly in the differentiation series. So basically, the value of the gradient at P is going to equal f dash of the x at P, which is f dash of 4. So basically, f dash of 4 is going to equal 4 into 4 squared plus 10 minus 7 into 4 power 1 over 2 over 4 times 4 power 1 over 2. If you plug that in the calculator, it should give you 1 over 2, 4 times 4 power half. That should give you an answer of 15 over 2. That is the answer. So this is the gradient value, okay, at point P, the gradient of the curve at point P. Now, double I says, hence find the equation of the normal to C at P. Okay, so we need the normal line, the line that is perpendicular to the tangent of the curve at point P. So let's say this is the curve. Okay, let's say this is point P. I have the tangent, okay, which will have a gradient of 5 over 2. Okay, I need to find the equation of the normal line, which is going to be perpendicular to this tangent. First of all, I know that it's a straight line, so it will have an equation y equals mx plus b, or mx plus c, whatever you call it. So I need m and b in order to solve. M I can find straight away because the m of the normal line is going to be related to the m of the tangent line. Because if we have two perpendicular lines, their slopes or their gradients are having a relationship, okay? So what's the relationship is that the slope of the normal line is going to be negative reciprocal of the slope of the tangent line. Okay, so negative 1 over m tangent. Okay, so what I like to think about it is that the equation of the slope of the normal line is going to equal to, you flip the gradient of the tangent line, so it becomes 2 over 15, and you multiply by minus 1. So this is now the gradient of the normal line. So up till now, for the normal line, I have y equals m, which is negative 2 over 15, x plus b. Now I'm almost halfway there. I need just to find what is b, and now I'm done. I have the complete equation for the normal line. That's the normal line equation. So how do I find b? I can use the point, because this is the point b. It lies both on the tangent and on the normal. Okay, so I can use it to find b. So I can substitute x with 4, y with minus 1 to find b. So y minus 1 equals negative 2 over 15 times x, which is 4, plus b. So now I'm going to have this as negative 2 times 4 is basic, so it's negative 1 equals negative 8 over 15 plus b. Move this to the other side, b becomes minus 1 plus 8 over 15. So b is equal to negative 7 over 15. So the equation, now you have to always remember to rewrite the equation of the normal line, which is going to be minus 2 over 15 x minus 7 over 15, and that is going to be my final answer for part A double I. Okay, now let's read the part that we're interested in. It tells me find f of x. Again, it started with, I don't think I need that anymore. It started with f dash of x, and it wants to reach to f of x. So I straight away know that I need to integrate to find my answer over here. So let's see how we will integrate f dash of x. First of all, I'd like to write it in a simpler way, which is an integratable way. I will divide everything by 4x power half. So this term is dividing 4x power half, and I'm gonna write them on separate terms. So this is gonna be 4x squared over 4x power half plus 10 over 4x power half minus 7x power half over 4x power half. So let me simplify this. 4 and 4 will cancel. Again, we will subtract the powers. So this is going to be x power 2 minus half is basically 1.5 or 3 over 2 plus 10 over 4. So I can divide 2, so it's going to be 5 over 2. And then this x, I want it on top. So I'm going to have it as x power negative 1 over 2 minus 7 over 4. X power half and x power half will cancel. So if you would like to think about it, you're subtracting these two. So half minus half is 0. So you're going to end up with x power 0. Anything power 0 is basically 1, which is the same as just minus 7 over 4. So now this is the integratable way. So f of x is going to equal the integration of f dash of x times dx. So let's integrate that. This is going to equal x power, instead of 3 over 2, we add 1 to the power, so 5 over 2, and we divide by the new power. So we're dividing 5 over 2 is the same as multiplying 2 over 5, plus 5 over 2 x power, negative half plus 1 is half, dividing by half is the same as multiplying by 2 over 1, and this is minus 7 over 4x, and I cannot forget the constant of integration. So this is going to be 2 over 5x power 5 over 2, plus 2 and 2 will cancel. This is going to be 5x power half minus 7 over 4x plus c equals f of x. Now, in order to find c, again, similarly, we'll have to use the point that lies on c. So we'll use p4 and 1. We'll substitute x with 4, y with minus 1. Sorry, it's minus 1. So 2 over 5 into 4 power 5 over 2 plus 5 into 4 power 1 over 2 minus 7 over 4 into 4 plus c. This should equal the y, which is minus 1. So all of this is equal to minus 1. So over here on the calculator, I'm going to do 2 over 5 times 4 power 5 over 2. That's going to give me 64 over 5 plus 5 times, okay, 4 power half is the same as root 4. So root 4 is 2. So 5 times 2 is 10. Minus 7 over 4 times 4. The 4's cancel, so it's minus 7 plus c equals minus 1. So I'll add all these together. So I will have 64 plus 10 minus 7. So it's basically 64 over 5. Sorry, 64 over 5 plus 10 minus 7. That is around 79 over 5 plus c equals minus 1. I'm going to subtract 79 over 5 from both sides. So that's going to give me a c value of negative 1 minus 79 over 5. That is a c value of minus 84 over 5. So that is my c. So I will come here in the original equation f of x. And instead of c, I'm going to change it. You have to rewrite it, okay, again. But I'm going to change it over here just for the sake of the video. Minus 84 over 5. And that is your f of x, okay? So you erase the c and you put minus 84 over 5. This is going to be your final answer, final simplified answer. And I hope it's clear. Let's erase all of this. Don't need it. Now, let's continue for the next question. Okay, this question is interesting, and it's an interesting idea that comes. It's called an improper integration. Why? Because as you can see, this is a definite integral. However, we have one of the bounds as infinity. So I'm going to teach you how to deal with this. So first of all, as always, let's write it in an integratable way. So this is going to be 2 into x plus 2 all to the power of minus 2. As I brought this to the top, it becomes power of minus 2. So integration from 1 to infinity of 2x plus 2 to the power of minus 2 dx is going to equal, when I have something like this, when I have a binomial in bracket, and for pure 1, that's all you will need to know. What you can do is you can treat this as a very big x, for example, okay? So what would you do for a normal integration? You would add 1 to the power and divide by the new power. So let's do that. So it's going to equal 2 into x plus 2. Let's just put the big bracket. X plus 2. Adding 1 to negative 2 becomes minus 1. And dividing by the new power, dividing by minus 1, basically just makes it a minus over here. Okay, and then an extra step, because this is not an actual big X, what we should do is we should divide the whole thing by the differentiation of what's inside. This is called the reverse chain rule, and I've gone through it in my integration series. I'm going to leave a link to the series in the top right hand corner. Feel free to go check it. This series is very useful because it goes through all the integration techniques that you will ever need in your life. So basically, yes, so after integrating, normally you're going to divide by the differentiation of what's inside the bracket, or the thing that was to the power of minus 2. So the differentiation of x plus 2 is basically 1, so we divide by the whole thing by 1, so it just doesn't make any difference over here. So this is going to be our integration answer. We have the bounds 1 and infinity. So over here, let me rewrite this as negative 2 over x plus 2, x plus 2, right? Because this is power negative 1, I can just plug it down to become x plus 2, and then the bounds are infinity and 1. So let's do what we know about the bounds. So let's substitute the upper bound and then minus substitute the lower bound. So it's going to be minus 2 over infinity plus 2, and then minus 2 over the lower bound, 1 plus 2. So over here, this part is fine. Okay, let's think about this part. Infinity plus 2 is basically just infinity, right? And when you subdivide a number with a very large number, the answer tends to go to 0. If you have your calculator and you want to try dividing minus 2 by 10 million or 100 million, you're going to find your answer as 0.0000 something. So negative 2 divide infinity basically tends to go to 0. So this whole part is 0 minus negative 2 over 3. So this becomes positive 2 over 3. And that is my answer for the definite integral. And for the definite integral, always our answer is going to be a number. It's not going to be an expression like in the normal integration where we find c and becomes the answer as 2x plus 3, for example. That's our final answer. No, in definite integral, you will have your answer as an actual value, a number. Okay, so I hope that this was clear. Let's move on to the next question over here. Okay, application of integration. This question wants us to find the area, okay? And as I told you in the beginning of the video, to find the area under a curve, so the area under this curve, this shaded area, I need to integrate my curve with lower and upper bounds that relates to the area that I want to get. So here clearly I want to integrate from 0 to 4 because this is the region I'm interested in. So let's see how we can do that. The diagram shows the curve with this equation. The curve meets the axis at this point and this point. Find the area of the shaded region. So I'm going to do an integral of, I'm going to take it from 0 to 4 of this curve, which is already written in an integratable way over here, minus 5 over 2x power 3 over 2. And never forget to multiply by dx. Did I do it here? Yes, I did. Okay, good. Now, integration will go as normal. So 10x, 1 plus half is 3 over 2 times 2 over 3 minus 5x. 3 over 2 plus 1 is 5 over 2. So I'm going to multiply by 2 over 5. Then all from 0 to 4. Let's simplify a little bit. This is going to be 20. 10 times 2 is 20 over 3. X power 3 over 2 minus 5 and 5 will cancel. This is going to be 2x power 5 over 2, evaluating from 0 to 4. So let's evaluate this integral. Let's substitute the upper bound first, as always. 2 over 3 into 4 power 3 over 2. Let's put this in the bracket. Minus 2 into 4 power 5 over 2. And let's close the bracket. And then minus when we substitute the lower bound. So when I substitute 0 in here, this term becomes a 0, and 0 in here, this term becomes a 0. So this whole thing just becomes a very big fat 0. So now let's evaluate this. So 20 over 3 times 4 power 3 over 2 is basically 160 over 3 minus 2 times 4 power 5 over 2. That's going to give me an answer of 64. Subtracting them from each other, 160 over 3 minus 64 is going to give me an answer of yes, there was a mistake over here when I forgot to copy this correctly. This is 5 over 2, so the 2 will also cancel. So here there will not be a 2, and here there will not be a 2. So this is just going to be minus 4 power 5 over 2, which is minus 32 instead of 64, 32. And this is going to give me an answer of 64 over 3. That is my final answer. Good. Now, let's continue to the next question. Let's see. Okay, this question seems like an area question as well. However, this tells me that from part A probably was something that's not related to integration. So from part A, this point is at a position of 4 and 0. So the x here is 4. The diagram shows the curve with equation y equals 9 x power negative half minus 4x power negative 3 over 2. The curve crosses the x-axis at the point A. Find the area of the region bounded by the curve. So the region bounded by my curve, and by my x-axis, and the line x equals 9, the line y equal, the line x equals 9 is basically a line where all the points are at the same x, which is 9. So let's say this is 9 over here. So the line is going to be something like this, okay? So which area is bounded by the three things, the curve, the x-axis, and this line? It's very clear that it's this area over here. So this is the area that I need to integrate, okay? So I'm going to, first of all, write this as y equals, I'm going to substitute the 9x power negative 1 over 2 minus 9 times 4 is 36 x power negative 3 over 2. Okay, so now I need to integrate 9x power negative half minus 36x power negative 3 over 2 from, if I want this area, I will need to integrate from 4 to 9. This is the only region I'm interested in. So from 4 to 9 and multiply by dx. This is going to equal, let's integrate, so it's going to be 9x power 1 over 2, divide half, same as multiplying 2, minus 36x, negative 3 over 2 plus 1 is minus half, and then divide minus half is the same as multiplying negative 2 over 1, so I'm just going to multiply negative 2 from 4 to 9. So this is going to be 18x power half minus 36 times negative 2 is going to basically be plus 36 times 2 is 72 x power negative half, and I'm evaluating from 4 to 9. So let's evaluate, let's substitute 9, so it's going to be 18 into 9 power half plus 72 into 9 power negative half, all in a bracket, and then minus 18 into 4 power half plus 72 into 4 power minus half. Evaluating this, 9 power half is 3, 18 times 3 is basically 54. This is going to be 9 power negative half is the same as over 9 power half, so over 3, so 72 divided 3 is basically plus 24. Then minus 18 times 4 power half, so times 2, so 36 plus 72 over 4 power half, so over 2, so 72 divided 2 is 36 over here. So adding everything is going to be 54 plus 24 minus 36 in bracket plus 36. That's going to give me a final answer of 6. And this is going to be my area over here. Okay, let's go to the next question. The next question is also an area question. So let's read it. The question basically tells me that there is a diagram that shows the curve with this equation. Line y equals 5. So line y equals 5 is a horizontal line at y equals 5. And that it intersects the curve at the points 1 and 5, 16 and 5. Calculate the area of the shaded region. Okay. To calculate the area of the shaded region, I need to think about what I'm going to do here. So first of all, this line, if we forget the curve and just think about this line, we can get this whole area, right? By integrating this line, okay, from 1 to 16, we can get this whole area. However, we're not interested in this whole area. We want only this part. So what if we, at the same time, find out the area that's bounded by the curve and the x-axis? So this area, okay, and remove it from the whole thing. So if we remove the green part from the red part, let's draw the red part like this. So if we remove the green part from the red part, so remove the green part from the whole, we're gonna end up with this shaded region only. This is what we want to do. So what I'm going to do is I'm going to find the area of the line and subtract from it, find the area under the line from 1 to 16 and subtract from it the area under the curve from 1 to 16. There are two ways that you can do them. I'm gonna solve this one way and another question I'm gonna solve it the other way. So first of all, I'm trying to find the area from 1 to 16 of the line y equals basically 5, so 5 dx. And then subtract the area from 1 to 16 of the curve, which is x power half plus 4x power minus 1 over 2 into dx. Okay, so integration of 5 is basically 5x from 1 to 16 minus, let's integrate this, so this becomes x power 3 over 2 times 2 over 3 plus 4x power 1 over 2 times 2 from 1 to 16. This becomes 5 times 16 minus 5 times 1 is basically 75, so this is 75 minus 2 over 3 x power 3 over 2 plus 4 times 2 is 8 x power half 16 to 1, so this is 75 minus 2 over 3 into 16 power 3 over 2, it's 8 into 16 power 1 over 2, minus, substituting the lower bound, so 2 over 3, 1 power 3 over 2 is basically 1, so 2 over 3 times 1, plus 8 times also 1 over here. So now evaluating everything on the calculator, 75 minus this minus is for the whole thing, so I should have a big bracket over here. Okay, so 75 minus, open a big bracket, 2 over 3 times 16 power 3 over 2 plus 8 times 16 power 1 over 2, then minus 2 over 3 plus 8 in brackets. This is going to give me an overall answer of basically just 9 units squared. And this is going to be my area over here. Okay, let's move on to the next question. I think we can reduce this. Let's see if that's better. I think that's better, yes. So let's continue. Let's remove this. Okay, we can leave it for now. Now, this question is also very important to understand. The question here says that the diagram shows the curves with equations y equals 9 over 4x squared minus blah blah blah, and another curve with the equation y equals 18 minus 3 over 8x power 5 over 2. The curves intersect at these points. So this point 0 and 18, and this point 4 and 6. Says find the area of the shaded region. So again, what we're going to do is find the area of under the big curve, which is the 18 minus 3 over 8 x power 5 over 2, and then find the area under the small curve, which is this area over here. Right? So imagine you have the whole thing, you have this whole thing, okay, and you remove from it this green part, you're gonna end up with this red part, right? So if you have the whole thing and remove from it the green part, you're gonna end up with the gray part, which is the part that you need. So this is what I'm going to do. I'm gonna solve it in another way. Remember, in the last question, what we did is we wrote the integration of this, so this area minus this area. What you can do also is that you can subtract the two functions from each other. So you can do a whole big integration from 0, x of 0 until x of, here they intersect at 4 and 6, so 0 to 4 of the two functions subtracting each other, the top function minus the function on the bottom. So I'm going to do 18 minus 3 over 8 x power 5 over 2. This is the top function minus a big minus, okay, the function down, which is 9 over 4 x squared minus 12x plus 18 all into dx. So right here, let me simplify this. So 0 to 4, 18 minus 3 over 8x power 5 over 2 minus 9 over 4x squared minus times negative 12 is plus 12x, and then minus 18 all into dx. So I can see that 18 minus 18, they will cancel, and I'll just end up with integration 0 to 4 of negative 3 over 8 x power 5 over 2 minus 9 over 4x squared plus 12x dx, and this is the expression that I need to evaluate to find the answer. So let's start by integrating first. So this is going to be minus 3 over 8 x, 5 over 2 plus 1 is 7 over 2. Then I'm going to multiply by 2 over 7 minus 9 over 4x cubed, and then I'm going to multiply by 1 over 3 plus 12x squared over the new power, which is over 2. So that's straight away this from 0 to 4. So now let's simplify. This is going to be negative 6. So 3 times 2, 6, and 8 times 7 is going to be, so it's negative 6 over 56, x power 7 over 2, minus 9 divide 3, so that's going to be 3, so it's going to be 3 over 4x cubed. 12 over 2 is 6x squared from 0 to 4. So let's substitute 4 first, so it's going to be minus 6 over 56 into 4 power 7 over 2 minus 3 over 4 into 4 power 3 plus 6 into 4 squared. Then minus, when I substitute 0, however, when I substitute 0 here, that's going to be 0. Here is 0, here is 0, so it's just minus 1, 0. And the final answer, when I plug everything on the calculator, negative 6 over 56 times 4 power 7 over 2 minus 3 over 4 into 4 power 3 plus 6 into 4 squared minus 0. That is going to give me a final answer of 240 over 7, and that is going to be my final answer over here to this question. Okay, now let's move on to the next question. Okay, that's an interesting one. It's a new type of question. This question says, the diagram shows the curve with this equation. The shaded region is bounded by the curve, so by this curve, and the lines x equals 1, x equals 2, and the x-axis. The shaded region is rotated 360 degrees about the x-axis. So this region, we want to rotate it 360 degrees about the x-axis, and rotating it, it will create a 3D shape for us, and we are asked to find the volume of that 3D shape. So if I quickly redraw what's happening, we have the curve, and we have this and this, and we are said that this whole region is rotated 360 degrees. So let's say we mirror this curve over here, okay, and mirror these, yeah. So this is going to be the rotation. After rotating, okay, I'm going to have this part, that's only this part is going to be rotated. So I'm going to have a 3D shape that is basically like this. It looks like a cylinder, basically, okay? So how to approach these questions? You need to approach them in this way. First of all, we're rotating about the x-axis. That's valuable information, because sometimes you can rotate also about the y-axis. Let's say if you want to rotate this region, it's going to become rotated about the y-axis. However, we're rotating about the x. So what we do here, it's called, we find it using the disk method. So what we do is, we know that this region, okay, this is an area, okay, let's simplify it into small rectangle, or like cut it up into small, basically small rectangles over here. So let's say this is the first rectangle over here, this is the second rectangle, and so on, okay? And then we rotate these rectangles, or these small discs, okay? So when you rotate this rectangle, it's gonna look something like this, right? So when you rotate it, it's gonna look something like this. So it's gonna be a disc. It's gonna look like a disc. Oh, if we take this part outside, it's basically something that is like this. And when you rotate it, it's gonna become basically a disc with this part in the middle, not there. Anyways, so this disc is basically, if I look at it from this view over here, is going to be something that looks like this, right? and it has a thickness. It has the thickness, and this is the thickness of the disk. Okay, so what we're going to do to find the volume is that we're going to cut up this area into very, very small, lots and lots and lots of small rectangles. Okay, lots of small rectangles like here. Okay, lots and lots of small rectangles. Okay, and rotate each rectangle to form disks. So we're gonna have lots and lots of disks. Okay, we are going to get the volume of the disks of each disk and add it up all together, add all the disks up together, and this is going to give us the volume of the whole thing. So let's think about how we're going to get the volume of the disk. So a volume of a disk is basically going to be, the volume of a disk is going to be the cross-sectional area of the disk, which is going to be this cross-sectional area, this circle, and we have to multiply it by the length of the disk, or like the thickness of the disk. Okay, so let's do that in our graph over here. What is the area of a circle? Is basically pi times r squared times the length. Okay, so the radius of the disk, is going to be this measurement over here, right? Which is basically this measurement, which is basically related to our y curve, because the radius here is going to be only this measurement. The radius here is going to be this measure. So it looks like the radius is always our y value, right? So our radius is going to be y, correct? And our length, or our thickness, which is the thickness, let's call it dx. So it's a very, very infinitesimally small distance x, because we said we're going to divide it into infinite squares. Okay, so the length is going to be dx. So what we're going to do is we're going to add up, so integrate all of these volumes of disks. Okay, so one disk volume is going to be the area, which is pi times r squared. Instead of r, we know r is the y, so y squared, multiply dx. So this is the equation that we're going to use to solve over here. So integration, okay, of pi of y squared. What is y? Y is basically 1 over 3x minus 2 power 3 over 2, and we need to square this whole thing, okay, and then into dx. And now we want to integrate from 1 to 2, so these are going to be our bounds over here. So if we wanted to simplify this a little bit, we can expand the power. So it's going to be, let's put the pi outside. So this is going to be 1 squared, which is 1 over 3x minus 2 power 3 over 2 all squared, right? So when I have something like this, you know that I multiply the powers. So it's going to be 3 over 2 times 2. The 2's will cancel, so it's just going to be power 3. So it's going to be 3x minus 2 all to the power of 3. So I can rewrite it, bringing it up. I just like to have it as 3x minus 2 to the power of minus 3. Okay, so let me erase this whole thing and just write it as 3x minus 2 to the power of minus 3. Now, this is my integration that when I solve it is going to give me a number, and that number is going to equal to the volume of the rotated shape. So now let's integrate pi of, again, we're going to use the inverse chain rule. Okay, so we're going to act as if this is all just one thing. So it's going to be, this only works when the x power is 1, by the way. Okay, when it's 2 or 3 or whatever, we have other methods, and I'm going to teach you later in pure 2, so stay tuned. So adding 1 to the power, so becomes 3x minus 2 plus power negative 2, dividing by the new power, so all over minus 2, and then we cannot forget to divide by the differentiation of what's inside. So what's the differentiation of 3x minus 2? Basically 3. We divide by 3 is the same as multiplying by 1 over 3, and we evaluate this from 1 to 2. So this is equal to pi into 3x minus 2 power negative 2. This is negative over 2 times 3 is basically 6. So that is going to be 1 to 2. That is our expression right here. So it's pi into negative 3. I'm going to substitute the upper bound first. negative 3 into 2 minus 2 over 6. Okay, and then this pi is multiplying everything, minus negative 3 into 1 minus 2 over 6. Okay, so this is going to be pi into minus 3 times 2 is 6, 6 minus 2 is 4, so minus 4 over 6, and then minus times minus is plus, and this is going to be 3, 3 minus 1 is basically, 3 minus 2 is 1, so it's 1 over 6, and over here, this is going to equal negative 4 over 6 plus 1 over 6 is basically, there must be something. Yes, this is power negative 2. We forgot to put power negative 2. So this is going to be power negative 2, and this is going to be power negative 2. Let's check. Yes, so evaluating this in the calculator is going to give us pi into 5 over 32, or basically 5 pi over 32, and that is going to be the final answer to this question over here. Okay, now let's continue. Let's take another question. This is also a volume question. However, here it's a little different. The diagram shows part of the curve with equation y equals x squared plus 1. The shaded region enclosed by the curve y-axis and the line y equals 5, so this is the curved or the shaded region, is rotated 360 degrees about the y-axis. So we need to take care over here. So we're rotating now about the y-axis, so let's copy it. And let's say we're also going to do the same thing. We want to divide it into very small rectangles over here, very small rectangles, and when we rotate one rectangle about the y-axis, is going to give us something like this. So we're gonna have this disk basically over here. So this disk plus the disk above it plus the disk above it plus is going to give us the whole volume of the whole thing. So we need to get the volume of this disk added to the volume of this disk, added, basically infinite disks. That's why we use the integration. The idea of integration is adding infinitely small number of things. Okay, so we need to know what's the volume of one single disk. So we know volume of a disk is basically the circular cross-sectional area, because a disk looks like this. So it's going to be pi times r squared into the thickness of the disk, which is going to be the small jump in y. We're going to call it dy. So dy over here. Okay, so volume is going to be integration of this stuff. What is going to be my radius? My radius, basically, this is the radius of the disk, right? This is the radius of the disk, right? So this is the radius of the disk. This is the radius of the other disk. So this is the radius of the third disk, right? So the radius is basically my x values, So my radius is going to equal x, right? So over here, what I need to do is I need to find the expression for x first. So I know that y equals x squared plus 1. So I can move that 1 to the other side and square root. So x is going to equal square root of y minus 1. That is the expression for x, and that is going to be my radius. So now let's copy this over here. Integration from, okay, I'm integrating dy with respect to y. So my bounds should be also on the y-axis. So I'm integrating from 1 to 5. So my bounds are going to be 1 to 5 of pi into r squared. What is r? R is basically my x, which is square root of y minus 1. So r to the power of 2, and then dy. Evaluating this will give me the final answer. So this is going to cancel. I'm going to have 1, 5. Let's put the pi outside of y minus 1 dy. This is very easy. Let's integrate. So this is going to be pi y squared over 2 minus y from 1 to 5. This is going to be pi, big bracket, substitute the upper bound, so 5 squared over 2 minus 5, and then substitute the lower bound, 1 squared over 2 minus 1. So that is going to be pi into 25 over 2 minus 5, that's going to be 15 over 2, and then minus, this is going to be 1 squared over 2 minus 1, which is negative half. So this is going to be 15, so this is going to be plus 15, so 16. 16 over 2 is 8, so my final answer is going to be 8 times pi. This is going to be my final answer for this question. I really hope that this video was helpful. Okay, I'm gonna do lots and lots of more videos like this, literally solving over and over and over practice past papers, because this is what will make you get your grade that you want. Please don't forget to subscribe, like, and comment down below any suggestions or questions or any improvements you want to see in the next videos. Thank you so much for watching, and have a nice day.